So start off in this question by sketching f of x and g of x. So f of x, square root function, you see here. So we can see straight away that when we sketch this, we are going to have a reflection. So this is going to be a reflection in the x-axis. So square root function looks like this. So our graph's going to be down like this. So we move 2 units to the right and 1 unit down. So it's going to be 2 along, 1 down. So my function is going to look like this. So my end point here is going to be 2 minus 1. And that is f. So looking at g here, another parabola. So x squared has been moved down 3, so x squared minus 3. So it'll be like this. So we can look at just doing a domain and range table for both of these. So thinking about the domain of f, first of all, you see this first value is going to be 2. And then we'll begin up to infinity. Domain of g for a quadratic with no restrictions is going to be r. The range of f is going to be, first value is going to be negative infinity, and the last value going up to minus 1 including. And then the range here is going to be minus 3 to infinity. So what we want to do here is find the domain and range of h, and h of x is g of f of x. So what I'm going to do here is just look at this. I'm going to start off with x. First function that I'm going to perform on it has got to be f, and then after that you will then perform g on that. So you're doing g of f of x, which is your composite function, h of x. So looking at the first part here, starting off with the domain of f, and we always get out the range of f. Second part of the composite function g starts off with the domain of g, and then we'll end up with the range of g of f. So this is the key part here to showing that it exists, it doesn't exist. So the domain of f is going to be 2 to infinity. Range of f is negative infinity to negative 1. Domain of g, actually going to be all real numbers. So you'll see here, this is going to exist because the second part of the composite function g works for all real numbers. So there's no values that you'll get out here in the range of f from the first part that are going to stop the second part working. Therefore it exists. So as it does exist, we then know that the domain of h of x, so g of f of x, is going to be equal to the domain of f, which in this case is going to be 2 to infinity. Okay, so looking at the range now, the range of h is a bit harder. But what we need to think about here is the second part of the function is g, but the domain of g is no longer going to be r, because we're only going to be using the values that we get out from the first part of the composite function. So instead of this value here, with this being here r, the domain is going to become negative infinity to negative 1. That's going to be the domain of the second part now. So if we look at that on the graph, we're just going to find, so negative infinity to negative 1, this is what it's going to be. So this is how we're going to work out the range using just this part of the function. Because no longer do we have all real numbers, because we're only using these values here on this second part g. So this coordinate here you see is going to be minus 1. And then subbing minus 1 into my function here, x squared minus 3, it's going to be minus 2. So therefore, to work out the range is just going to be with this red part here. So the range is going to be from minus 2. Okay, so we just write that here. The range of h of x is going to be minus 2 including, and up to infinity.